I think until unless if you don't have this, no way this problem, but better you can avoid this problem. If you don't know what is the maximum elongation conditions, at maximum elongation, what should be the relative velocity should be. Initially, what is the state of them? They were at rest. What is the U relative is 0. This is the very important point. At maximum elongation also, they'll be at rest. The relative velocity will be 0. There's a basic necessity condition. So let this acceleration, in what action they'll accelerate? That's the primary question. So let me assume that all. So this is M3, this one. So let there be acceleration be A2. Sir, why you are putting up or down? I too don't know. So then the spring gets elongated. The weight M1G sine theta. Okay, here only let me wind up rather than going for other problem. M2G sine theta. This is T. This is T. And this will be M3G. So acceleration of M2 and M3 should be same because they're connected by a common string. Let's get into first, we'll get the expression for acceleration. A1 should be equal to M1G sine theta. Masses are there. Okay, later on we'll substitute here. M1G sine theta plus elongation spring Kx by M1. This is the acceleration minus F. Yeah, I included here. This is the acceleration of the block M1. And then similarly, here what are the forces? M1G sine theta, Kx minus F, folded by M1. That is the acceleration of block M1. What about here? Tension M2G sine theta minus Kx, the spring force should act in this direction here. So this acceleration A2 should be equal to T plus M2G sine theta minus Kx by M2. So this is the acceleration of the second block. What is the basic necessity? And we'll write one more equation, M3G minus T equal to M3A2. Okay, I think this T we can eliminate, substitute there, we'll get expression for A2. So there's the equation 1. So what we are trying to find out the maximum elongation. We are trying to find out the maximum elongation. The value of T is what I'll substitute there. So this will be A2 is equal to, T should be M3G minus M3A2 plus M2G sine theta, M2A2, I'll write it, minus Kx. So this will become A2 equal to M3G plus M2G sine theta minus Kx equal to M2 plus M3. I think these are the very important equations. 1 and 2 is what I brought it. And let's come back. Okay, this is somehow anybody can write it. The spring will be elongated. Definitely look at the conditions. So will it be compression elongation? Will be elongated. Spring will be elongated right here. Spring is elongated. So therefore, the spring force should act toward the center of that one. So after getting this, what is the condition for maximum elongation? At maximum elongation, the relative velocity should be 0. The relative velocity must be equal to 0. I think this is a primary condition where all you go when the spring comes. No, there's a basic idea. So how to calculate the relative velocity? So for that, I'll go for A relative. A relative equal to A2 minus A1. This I think better rather than solving, we can substitute all the values. Will directly end up certain. So here let me calculate A2 and A1 values, so that it will be easy for me, because equation will become linear. This will be 10, M2 is 40, theta is 30 degrees. So this will be 20 minus spring constant 1000. This is X. M2 plus M3. M2 plus M3 is 5. Okay, 30 minus 5, this will be 6. This will be 200x. We can save time rather than writing that lengthy equations. No, I think when you do this, you'll get a better picture also. The M1 is 2, 20, 20. This will be G sine theta. I think this will be 5. K will be 1000x. 1000 by M1 is 500x. Value of F, I'm not seeing F. Oh, okay, 15 by 2, 7.5. 7.5. So this should be equal to 12.5. Is 1000 meter. Okay, this much is what we have. So let me go for the relative acceleration. A relative equal to, you can make this very simple. It is. So A relative should be equal to 6 minus 200x. So 6 minus 12.5. I think I have to check my calculation. M1 is 2, no? F by 15 by 2, 7.5. Check once. I think I'm.
Sir, A1 equal to 10 plus 500x, sir. We will not get 5, we'll get 10.
10, huh? This
Yes,
one?
sir.
M1, 2, 2, 2, this will be 10, 10, this will be 5. K will be 500x. F is how much? 15, no? 15 by 1. M1G sin theta plus Kx minus F by M1.
Correct only, sir.
Okay. This one. Sorry. This should be. Yeah, correct only, no? I think. 5 minus 7.5 will be 2.5. Minus 2.5. We were adding, no? It should be like a 2.5. Okay, this. No, I think now we'll get it. It's not 12, 2.5. Now, okay, I'm minus of 2.5. So this will become 8.5 minus 600x. What to do with this A relative? I write equal to 8.5 minus 600x. This will integrate. dx it is, dx. No. What should be the limits? Limits will be initially, what was the state? It was 0. Finally, at maximum elongation also, relative velocity should be 0. This will be xn. I think the problem has become very simple with this approach. You try to go any other thing, not possible. You can do by work done, very lengthy. Always maximum elongation, there's a condition. What are the forces that are acting?
Sir, it is 700, sir, not 600.
Okay, 700. Yeah. So maximum elongation will be 2.4 centimeter. And I have answer. Now substitute that value of xm, calculate acceleration. If we get negative, what we assumed is opposite. See, it doesn't matter. A1 and A2, sir, are you sure? Maybe A1 will be upward, it will be downward. Or A1, A2, both will be upward. So we are not very sure what actually happened. There's a beauty of this problem. So now we'll substitute. So x equal 2.4. So this will be in meters you substitute now. So you will get it. Acceleration of the system at this instant is asking. I think at maximum elongation, all must have common acceleration. A relative should be 0. So A1 should be equal to A2. check it, you'll get it. What do you mean by negative sign? At maximum elongation, blocks will be sliding up. Blocks M1 and M2 will be sliding up the incline. This much is what we are putting here. So if you start jumping into the work done by the gravity, work done by spring force, I think somewhere will get stuck. Very difficult.